I'm Dr. Rachel Platel and I work at the chemistry department at Lancaster University as a lecturer. Think back to the 1800s and try to imagine yourself as a scientist. What sort of safety measures do you think existed in those times? What scientific equipment would have been available to you? In this short video, we will be exploring the differences between how we do chemistry research in the 21st century compared to Sir Humphrey Davy's time in the 1800s. One of the most striking differences is in health and safety regulations and the safeguarding of researchers working with hazardous materials. This laboratory was built in 2015 and is designed for use by researchers working in the area of synthetic chemistry. This area of chemistry is concerned with making and investigating the properties of new molecules, so we're actually working in a similar area to Davy. However, as Davy found when he experimented with breathing nitrous oxide, many of the chemicals encountered in chemistry research are inherently toxic to humans. In this lab, there are a number of vented fume cupboards, and these have built-in extraction, just like a cooker hood, and mean that we can work with quite toxic substances, but not be exposed to them. There is also a lot more known now about the toxicity of chemicals, and a system of hazard classification, shown here, and control measures has been developed to help researchers work safely with toxic substances, but without putting themselves or others at risk of exposure. One of the control measures is the use of personal protective equipment, or PPE, a lab coat, safety spectacles, and sometimes gloves. In contrast, there was no legislation around scientific research in the 1800s, so Davy would have been able to work exactly as he wanted. In the 1800s, chemists had far less prior knowledge to base their research on than we have today. The behaviour of elements is dependent on their position in the periodic table, which was not published until 1869 by Mendeleev. Davy is credited with the discovery of 9 elements, and his work predates the periodic table as we know it today, so he was very much working in the dark. The chemistry he did was therefore of a far more fundamental nature than the chemistry we do nowadays. Many of the fundamental concepts that are central to the way we think about science and chemistry were only developed in the 1900s. In the 1800s, not much was known about the structure of atoms. They were thought to be solid spheres like snooker balls or these tennis balls, and ideas about quantum chemistry and physics, on which modern science is based, were still a long way off. There are many differences between the scientific equipment at our disposal here and the instruments that Davy would have used. As chemists, we probe the nature of chemical bonds in compounds and thus understand and rationalise their behaviour. For instance, this infrared spectrometer tells us what bonds are present in a molecule by analysing their vibrations. We can often get the results in just seconds or minutes, whereas many of the techniques did not actually exist in the 1800s. Then, most materials were investigated through their behaviour with other things, such as water and acids. New materials were routinely tasted to see if they had an acidic or a soapy taste. We also have access to equipment that allows us to work with highly reactive materials. This glove box is filled with nitrogen gas, which is inert, meaning we can easily handle materials that would spontaneously combust upon contact with atmospheric oxygen. Whilst we have explored some of the differences between chemistry research in the 1800s and today, it's interesting to reflect on what has not changed. Despite many technological advances that make electronic note-taking possible, still by far the most reliable method of recording progress in research is by hand using a physical laboratory notebook. This creates a permanent record of experiments done and their results, which can be made in real time in the lab and kept forever. Researchers in the 21st century are driven by their curiosity of all things chemical and the quest to make new discoveries and advances in the field of chemical science. It is this shared curiosity which links us to those earlier generations of researchers on whose shoulders we stand.